Let's do our estimate first. And we might think about money. That may help you a little bit for this example. So I'm wanting to share 0.6, so less than 1, into even smaller groups of 0.03. That might be a little bit difficult to visualize. So you can keep in mind that the dividend is bigger than the divisor. So the answer will be bigger than 1. Another way is to think about money. Imagine having 60 cents, 0.6. So 60 cents, and you're sharing into groups that are worth 3 cents each. So if I had 60 cents and I was dividing into groups of 3, my answer should be much bigger than 1. You might be snazzy. You might be able to actually work out the answer in your head at that point, and if you have already, that's fantastic. That's great number sense. If not, we'll keep going. So thinking during, I'm unable to put these numbers into my algorithm, and the reason I can't use that short or long division is because for the algorithm, the divisor, that's the second number here, cannot be a decimal. The algorithm does not work correctly if the divisor is a decimal. So we're going to have to do something about that. And we use our sense of sharing and proportion to help us. So I'm going to write down my division again, 0.6 divided by 0.03. And what I'm going to do is make what I'm sharing 10 times bigger. And I could make it 2 times bigger, I could make it whatever I want, but I'm going to multiply by 10, because when I multiply by 10, all I do is shift those digits to the next place value. So 6 moves to its next place value column, which means that's going to move there, and I'm also, as well as what I'm sharing is getting bigger, I've got to make those groups bigger so I get the same proportion, the same number of groups when I'm done. So if I make it 10 times bigger each number, I've got another division here, 6, and this has moved to 0.3. So 0.6 divided by 0.03 will give me the same answer. It's equal, or it's equivalent, we say, it's worth the same as 6 divided into groups of 0.3. My divisor is still not it's still got the decimal in there, so that's still no good. I'm going to go an extra step. I'm going to make it 10 times bigger again. Now, if you were a bit faster than me and you spotted that that was never going to work successfully all the way, and you multiplied by 100 in the first step, that's fantastic. We're going to multiply each of these, moving into the next place value column, because we're 10 times bigger. Our system is 10 times, is base 10. So I've got 60 divided by 3. So 60 divided by 3, and I know the answer to that, it's 20. Don't even need an algorithm for this one. 60 divided by 3, or 60 shared into groups of 3, is the same as 6 shared into groups of 0.3, or 0.6 shared into groups of 0.03. We're sharing a bigger amount, 10 times bigger, and the groups we're making are 10 times bigger. So that's why we continue to get the correct answer, because both numbers are being made bigger by the same factor. Now if I want an after here, I guess I could do an algorithm if I wanted to. You could set up the algorithm and you'd soon get 20, so you could check it that way, and you could also go and check it by looking at your estimate. And if you still weren't convinced, you could write 0.6 as a fraction and 0.03 as a fraction of 100, and multiply by the reciprocal, leaving that first fraction alone. Just Just give yourself a little bit more room then. And then I'm going to do some cancelling at this point to make life easier later. I'll divide this numerator and this denominator by 10. I'll divide this numerator and denominator by 3. Dividing each by 3. And now I just multiply 2 by 10 is 20. 1 by 1 is 1. And the answer, no matter which way you go, whether you get a rough answer, make each number larger and do the division in your head, use an algorithm, or go with the fractions, you should, no matter which way you choose, you should be ending up in the same with the same answer. And that's how you can be really confident that things are going well and things make sense for you.